Hi students, this is Ms. Overly with lesson 9-4, compositions of transformations. By the end of this lesson, you will be able to draw compositions, which is just a fancy way of saying more than one transformation. So you'll be able to draw those compositions of transformations on coordinate planes. And because of this reason, you will need some graph paper. So please pause the video until you're ready to start with graph paper. All right, example 1. Triangle JKL has vertices as listed here. Graph triangle JKL and its image after a translation along 0, 4, and a reflection in the y-axis. So this combination of two transformations, again, is what we call a composition of transformations. So let's start by step 1. Well, how can I do this? Talking about what that translation is going to look like along 0, 4. So the x stays the same, and for the y, we add 4. So that translation just means we're going to slide our triangle over. Actually, in this case, we're sliding it up 4. So I like to rewrite all of the ordered pairs one more time. So rewrite them by adding 4 to all of the y's. So x stays the same for each of these ordered pairs, and for y, we add 4. So that's the first part of our transformation, the translation piece. Now we need to reflect over the y-axis. And remember, the trick with reflections is that you are doing the opposite of what you'd think. So since it's over the y-axis, it's actually x that becomes opposite. So again, I like to write down my ordered pairs for that image. So this is our pre-image, this is the image. And now that we've done a composition of transformations, our new image, we give 2 prime marks to show that it's been transformed yet again. So finally, we have these new pairs, and now we need to graph them. So why don't you pause the video, graph all 3 triangles, labeling them as JKL and J prime, K prime, L prime, and J double prime, K double prime, and L double prime, and then play the video to check your work. All right, example 2. Actually, before we go on to example 2, I just want to remind you quickly of what we talked about with rotations. To do a 90-degree counterclockwise rotation, we use this rule, opposite of y. To do a 180-degree rotation, we take the opposite of both x and y. And to do a 270 degrees counterclockwise rotation about the origin, we make x opposite. So keep that rule in mind for each of these as we go into our next example. Example 2, we are going to just look at a line CD with endpoints as listed here. You're asked first to graph that line and its image after a reflection over the x-axis. So right now in my head I'm thinking, okay, reflection over the x-axis tells me it's really the opposite of what I'm thinking, so opposite of y, so I'm keeping that rule in my head, and a rotation of 90 degrees about the origin. So I'm keeping this rule in mind, opposite y, x. So again, I like to write out my new ordered pairs first for each independent transformation, and then graph all 3. So let's do that here. Again, the first rule is going to be x, opposite of y. So take each of those points and see if you can write out their new ordered pairs and check, do they look like this? And our second transformation is a rotation of 90 degrees about the origin counterclockwise. So remember, our rule for that is opposite of y, x, as I listed up here. So see if you now could pause the video and write out the image points for that transformation, and then play it to check. And then finally, we just need to kind of check our graphing for all 3. Remember that after we've transformed this line once, we label our image with primes, and again, we label our image with double primes. All right, going on to example 3. And actually, in example 3, let's take a peek at example 3 first. They say to copy and reflect figure A in line M and then line P. Then describe a single transformation that maps A to A double prime. So in order to do this, we need two theorems. So please add these to your notes. The first one is the composition of two reflections in parallel lines can be described by a translation vector that is perpendicular to the two lines and twice the distance between the two lines. The second one is that the composition of two reflections in intersecting lines can be described as a rotation about the point where the lines intersect and through an angle that is twice the measure of the acute or right angle formed by the lines. So let's use that information in example 3. All right, so again, copy both of these images down, and you could actually open your book up to example 3 and trace them if that's easiest for you. But copy these images down and then think, what are we going to need to do to create this composition of transformations? All right, so again, we're reflecting figure A over line M and then line P. So let's take a look at what this will look like. Well, if we reflect figure A over line M here, we have A prime is there, and then over line P again, our image over P is drawn here. So if we think back to 9.2, it says when you have parallel lines, the qualities of your reflection will be perpendicular lines are created and twice the distance between two lines is formed. So the same thing occurs here. If we initially had 1.75 centimeters between line M and line P, now we can multiply that number by 2, and the distance between our image and our pre-image is 3.5 centimeters. So if we have intersecting lines, well, how does that change? If we reflect A over line M and then over line P, our pre-image and our image look like this. So we can see now that the angle that we originally had between those two lines is doubled. So the distance between these two, the image and the pre-image, is now 120 degrees. It's a 120-degree counterclockwise rotation. So you've now taken a look at compositions of transformations on coordinate planes, and you are going to have an opportunity to practice that in class tomorrow.